For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@nursingsassignmenthelp.com or reach us at https://www.nursingsassignmenthelp.com. Biochemistry Assignment Help. Oxidation reduction reactions in the mitochondrial respiratory chain. A. The NADH dehydrogenase complex of the mitochondrial respiratory chain promotes the following series of oxidation reduction reactions, in which Fe3+ and Fe2+ represent the iron in the iron-sulfur clusters, Q is the ubiquinone, QH2 is ubiquinol, and E is the enzyme. 1. NADH plus H plus EFMN NAD plus EFMNH2A, electron donor, NADHB, electron acceptor, EFMNC, reduction, EFMN plus 2H plus 2E EFMNH2D, oxidized, NADH NAD plus H plus 2E2, EFMNH2 plus 2Fe3 plus EFMN plus 2Fe2 plus 2H plus A, electron donor, EFMNH2B, electron acceptor, Fe3 plus C, reduction, 2Fe3 plus 2E 2Fe2 plus D, oxidation, EFMNH2 plus 2H plus 2 times 10 to the power of -3, 2Fe2 plus 2H plus Q 2Fe3 plus QH2E, electron donor, Fe2 plus F, electron acceptor, QG, reduced, Q plus 2E plus 2H plus QH2H, oxidized, 2Fe2 plus 2E plus 2Fe3 plus. Sum, NADH plus H plus Q NAD plus QH2. NursingAssignmentHelp.com. For each of these three reactions catalyzed by the NADH dehydrogenase complex, identify/provide, filled in above, A. The electron donor, B. The electron acceptor, C. The oxidation half reaction, with electrons and protons balanced if applicable, D. The reduction half reaction, with electrons and protons balanced if applicable, B. All of the dehydrogenases in glycolysis and the citric acid cycle use NAD+, E0 for NAD plus NADH is -0.32 V, as an electron acceptor except succinate dehydrogenase, which uses covalently bound FAD, E0 for FAD-FADH2 in this enzyme is 0.050 V. Suggest why FAD is a more appropriate electron acceptor than NAD plus in the dehydrogenation of succinate, based on the E0 values of fumarate succinate, E0 equals 0.031 V, NAD plus/NADH, and the succinate dehydrogenase FAD/FADH2. From the difference in standard reduction potential, delta E0, for each pair of half reactions, you can calculate delta GO. The oxidation of succinate by FAD is favored by the negative delta GO equals -3.7 kJ/mol. Oxidation by NAD plus has a large, positive delta GO equals 67 kJ/mol. Thus FAD is a more appropriate electron acceptor in this case. C. The degree of reduction of each carrier in the respiratory chain is determined by conditions in the mitochondrion. For example, when NADH and O2 are abundant, the steady-state degree of reduction of the carriers decreases as electrons pass from the substrate to O2. NursingAssignmentHelp.com. C. The degree of reduction of each carrier in the respiratory chain is determined by conditions in the mitochondrion. For example, when NADH and O2 are abundant, the steady-state degree of reduction of the carriers decreases as electrons pass from the substrate to O2. When electron transfer is blocked, the carriers before the block become more reduced, and those beyond the block become more oxidized. For each of the conditions below, predict the state of oxidation of ubiquinone and cytochrome C, A. Abundant NADH and O2, but potassium cyanide, complex 4 inhibitor, added, both would be reduced. B. Abundant NADH, but O2 exhausted, both reduced, because in the absence of O2, the carriers would not be reoxidized. C. Abundant O2, but NADH exhausted, both oxidized. D. Abundant NADH and O2, ubiquinone reduced, early in chain, but cytochrome C less reduced, more oxidized, because of abundant oxygen. TCA cycle intermediates, adapted from a previous exam. Arsenite is known to react with mercapto compounds, and thus it inhibits enzymatic reactions in which a thiol group is necessary. A. Show how liver tissue could metabolize pyruvate in the presence of arsenite, plentiful supplies of ATP, and reduced coenzymes. What compound would accumulate? NursingAssignmentHelp.com. B. In addition to the compound that accumulates in part, A. Show how glycogen could accumulate under these conditions. Fatty acid properties. Number the fatty acids below in order based on melting temperature, with the lowest melting temperature fatty acid being number 1. In addition, draw the fatty acid if its name is given and name the drawn fatty acid. NursingAssignmentHelp.com. 12:3 increment 5 8 11 20:0 16:0 12:2 omega 3 6 1 2 3 3 4 5 12 o'clock 12:1 increment 6. Fatty acid oxidation. A. How many net NADH, FADH2, CO2, and ATP can a single molecule generate when fully oxidized? Are there any other byproducts remaining? 3 CO2, 1 ATP equivalent, 9 NADH, 3 FADH2 and 1 molecule of OAA. NursingAssignmentHelp.com. B. If a diet consisted only of this molecule, could the organism net produce glucose? Yes, because we can produce a molecule of pyruvate. We know that we can use gluconeogenesis to turn this molecule back into glucose. Introduction to photosynthesis. A. Conceptually, oxidative phosphorylation and photophosphorylation have a lot in common. Fill in the chart below to indicate the similarities and/or differences between the two processes. OXPHOS photosynthesis light reactions. NursingAssignmentHelp.com. Energy source which drives the reaction NADH NAD plus H plus 2E FADH 2 FAD plus 2H plus 2E. Light. Compartment with low pH intermembrane space thylakoid space. Compartment with high pH mitochondrial matrix stroma. To create a proton gradient, both organelles use an electron transport chain. Motor protein required for ATP synthase, the generation of ATP synthase. High energy molecules that are produced by the cycle ATP NADPH. Additional products. Water oxygen. B. What role does water play in photosynthesis? Is it necessary? Water is an electron donor. It is required for NADPH production, but an electron donor is not required for cyclic electron transfer. NursingAssignmentHelp.com. C. What role does light play in photosynthesis? Is it necessary? Light provides the energy that drives photosynthesis. It is absolutely required to drive an otherwise endergonic reaction. D. One product of the light reactions in photosynthesis is NADPH. What is this reduced compound used for? NADPH is used to synthesize carbohydrates like glucose from CO2 by reducing it.